I am Pavun Raj, working as assistant professor in Veldtech Multitech, Dr. Rangarajan, Dr. Sakunthala Engineering College, Department of Artificial Intelligence and Data Science. Now I am handling the subject is like this software development process model. Software engineering. Software engineering is a process of designing, developing, testing, and maintaining the software. It is a systematic and disciplined approach to software development that aims to create high quality, reliable, and maintenance software. It includes a variety of techniques, tools, and methodologies, include requirements, analysis, design, testing, and maintenance. Classifications of the software. First one, system software. System software is necessary to manage computer resources and software executions of application program. A software like operating system, compilers, editors, and drivers, etc. Some common under this category, a computer cannot function without presence of this. The operating systems are needed to link the machine's dependent needs of the program with the capabilities of the machines on which it runs. Compilers, it translates the program high-level language to machine language. So next one is licensed software. So software can be classified as proprietary software or open source software. So development model. The software can be classified as traditional software or agile software. Size. Software can be classified as small scale software or entrepreneurship software. User interface. Software can be classified as graphical user interface software or command line interface software. Application software. The application software is designed to fulfill the user requirement by interacting with the user directly. It could be classified into two major categories, generic or customized. Generic software is a software that is open to all and behave the same for all of its users. Its function is limited and not customized as per the user changing requirements. However, on the other hand, the customized software is a software the product are designed per the client requirement and are not is available for all. Networking and web-based application software. Networking software provide the required support necessary for the computer to interact with each other and the data storage facilities. Networking software is also used when the software is running on the network computers. It includes all network management software, server software, security and encryption software, and software to develop web-based applications like HTML, PHP, and XML, etc. Embedded software. This type of the software is embedded into hardware normally in read-only memory as a part of large system and is used to support a certain functionality under the control conditions. Examples are software is used in instrumentations and control applications like washing machines, satellite and microwave, etc. So next one, software development life cycle. This is a software development life cycle phases. First one, planning. Second one, defining. And third one is designing. And fourth one, building. And fifth one, testing. Then last one is deployment. These are the software development phases. We can see one by one. The stages of the software development life cycle. STLC specify the task to be performed at various stages by a software engineer or developer. It ensures that the end product is able to meet the customer expectations and fit into overall budget. Hence, it is vital for the software developer to have prior knowledge of the software development process. STLC is a collection of 6 stages, and the stages of the STLC are as follows. Planning and requirement analysis. Planning. Planning is a crucial step for everything just in a software development and in some stages requirement analysis is also performed by the developer of the organizations. It is attained from the customer input and sales department and market surveys. The information from this analysis form the building a block of basic project. The quality of the project is a result of planning. Thus is in this stage the basic project is designed with all the available information. Defining requirement. In this stage, all the requirement for the target software are specified. The requirement get is approved from the customer, market, analytics and the stakeholders. This is fulfilled by utilizing SRS. SRS means software requirement specifications. This is a sort of the document that specify all those things that is need to defined and created during the entire project cycle. Stage 3 Designing Architecture. SRS is a reference for the software designer to come up with the best architecture for the software. Hence, the requirements are defined in SRS. Multiple design for the software architecture are present in the design development specification. This design development specification is assessed by market analytics and stakeholders. After evaluating all the possible factors, the most practicals and logical design is chosen for the development. Stage 4. So developing product. At this stage, the fundamental of the development of the product start. For this, developers use a specific programming code as per the design in the DDS. Hence, it's important for the coders to follow the protocols and set by the association. Conventional programming tools like compiler, interpreters, debuggers, etc. are also put into use of this stage. Some popular stages like C++, Python, Java or language is used in developing product stage, but are used in as per software regulations. Stage 5 the product testing and integration. After the development of the product, the testing of the software is necessary to ensure it is smooth executions, although the minimal testing is conducted at the early stage of the SDLC. Therefore, at this stage, all the probable flaws are tracked and fixed and retested. This ensures that the product conforms a quality requirements of SRS. Stage 6 Deployment and maintenance of the product. After detailed testing, the conclusive product is released in spaces as per the organization strategy. Then is tested real industrial environment. It is important to ensure it is smooth performance. If it is performed well, the organization sent out to the product a whole after retrieving the beneficial feedback by the company is released it as it for is actuaries improve to make further helpful for the customer. However, it is long alone is not enough. Therefore, with the deployment, the product supervision. Software development lifecycle. The software development lifecycle is a structured process that is used to design, develop, and test the high quality software. STLC or software development lifecycle is methodology that is defining the entire procedure for the software development step by step. The goal of the STLC lifecycle is to deliver the high quality maintainable software that meet the user requirements. The life cycle defines a method for improving the quality of the software and overall around the deployment process. Types. First one waterfall model, and the second one agile model, and third one beam model, and the fourth one spiral model, and the fifth one incremental model, and the sixth one rare model. First one waterfall model. The waterfall model is a software development model is used in context of the large complex project. Typically, in a field of Information technology in the characterized by the structured or sequential approach to project management and software development. The waterfall model is useful in situations where the project requirements are well defined and the project goals are clear. It is often used in large scale projects within long timelines where there is a little room for the error and the project stakeholders are need to have a high level confidence in the outcome. So waterfall model spaces, first one recruitment, second one design, and third one development, and fourth one testing, and fifth one deployment, and sixth one maintenance. These are the spaces of software, software development life cycle in waterfall model. First one's requirement analysis and specifications. So requirement analysis and specifications phase is aimed to understand the exact requirement of the customer and a document from the property. This phases is consists of the two different activities. So requirement gathering and analysis. First, all the requirement recording of the software are gathered from the customer and then is gathered requirement are analyzed. The goal of the analysis part is to remove the incompleteness and inconsistence. Requirement specifications. These are analyzed requirements are documented in the software requirement specification document. SRS document serves as the contact between the development team and customers, and the features distribute between the customer and the developers can be settled by the examining the SRS document. Design. The goal of this software design space is to convert the requirement required in the SRS into the format that can be coded in the programming language. It includes high-level and detailed design as well as the overall software architecture. A software design development is used in the document all of this effort, high-level design and low-level design. The design can be classified as high-level design and low-level design. High-level design, this space is focused on the outlining the board structure of the program. It highlighting the key components and how they are interact with each other, giving clear overview of the system architecture. Low-level design. Once the high-level design is in this space zoom into the detail. It breaks down the each component into smaller parts and is provide a specific about how each part will function in guiding the actual coding process. Third one is deployment. In the deployment spaces, software design is translated into source code using any suitable programming language. Thus each designed model is coded. The unit testing space aims to check whether each model is working properly or not. In this phase, the developer begins writing the actual source code based on the designers created earlier. The goal is to transform the design into working code using the most suitable programming language. Unit testing is often performed during this phase. We make sure that each component functions are correctly on its own. Testing and deployment. Testing. That integration of the different modules is undertaken soon after they have been coded and need tested. Integrations of various modules carried out of incrementally over several steps. So during each integration step, previously planned models are added to the partially integrated systems and the resultant system is tested. Finally, after all the modules have been successfully integrated and tested, the full working system is obtained and the system testing is carried out on this. The system testing is consists of the three different kinds of the testing activities. First one is alpha testing and second one beta testing and third one acceptance testing. So alpha testing. Alpha testing is the system designing performed by the development team. The beta testing is a system testing performed by the friendly set of the customers. Acceptance testing. After the software has been delivered, the customer performance acceptance testing determines whether they accept the delivered software or reject it. Deployment. Once the software has been thoroughly tested, it is time to deploy it to the customer or end user. This means making the software ready and available for use. Software is moving it to a live or stage of the environment. So during this phase, we also focus on helping users get comfortable with the software by providing training and setting up necessary environment and ensuring everything is running smoothly. The goal is to make sure the systems work and expected in real world conditions and that the user can start using without any without hitches. Fifth one, maintenance. In maintenance space, the most important space of the software development lifecycle, the effort spent on maintenance is 60% of the total effort spent to the development. A full software. There are three types of the maintenance. First one, corrective maintenance, and second one for perfective maintenance, and third one is adaptive maintenance. So corrective maintenance. This type of the maintenance is carried out to the correct errors that were not discovered during the product development phase. Perfective maintenance. This type of the maintenance is carried out to enhance the functionalities of the systems based on customer request. Third one is adaptive maintenance. So adaptive maintenance is usually required for the protecting the software to work the new environment, such as working on the new computer platform or a new operating system. Features of the waterfall model. Sequential approach. First one, sequential approach. Second one, document driven. And third one, quality control. And fourth one, rigorous planning. First one, sequential approach. The waterfall models involve the sequential approach to software development where each phase of the software is completed before moving on the next one. Document driven. The waterfall model is dependent on the documentation to ensure the project as well as defined in the project team is working towards a clear set of the goals. Quality control. The waterfall models place the high quality emphasis control are testing each of the space of the project to ensure that the final product meets the requirement and the expectations of the stakeholders. Rigorous planning. The waterfall models involve the careful planning process where the project scope, the timeline, and its deliverable are carefully defined and monitored throughout the project lifecycle. Importance of the software Importance of the waterfall model, clarity and simplicity. First one, clarity and simplicity. So linear form of the waterfall model is offer the simple and unambiguous foundation for the project development. It's clearly defined phases. So waterfall model phases each have unique input and outputs guaranteeing the plant development with a visuous checkpoint. So documentation. A focus on the through the documentation on help the software comprehensive maintenance and future growth. Stability in requirements is suitable for the project when the requirements are clear and stable and reducing the modification as the project progress. Resource optimization. It encourages effective task focus work without continuously changing context by allocating the resources according to the project phases. Relevance for a small project, economical for the most project with the simple specifications and minimum complexity. So advantages of the waterfall model, easy to understand. The classical waterfall model is very simple and easy to understand. Individual processing, a basis on classical model are processed once at a time. properly defined. In classical waterfall model, each stage in a model is clearly defined. A clear milestone. The classical waterfall model has a every very clear and well understood milestones, properly documented. Process, actions, and result are very well documented. Disadvantages of waterfall model. No feedback path. In the classical waterfall model, evolutions of the software from one space to another space is like waterfall model. It assumes that no error ever is committed by developer during any phase. Therefore, it does not incorporate any mechanism for error correction. Difficult to accommodate changes in request. This model is assumed that all the customer requirement can be completely and correctly defined in the beginning of the project, but the customer requirement keep the changes with time. It is difficult to accommodate any changes requested after the requirement specification phase is complete. No overlapping of phases. These models recommend that the new space can start only after the completion of the previous phase, but its real project it cannot be maintained. It increases effectively and reduces the cost phase may overlap. It's limited flexibility. The waterfall model is a rigid and linear approach for software development, which means it is not well suited for the project with a changing or uncertain requirement. Once the spaces can be completed and it's difficult to change or back to previous space. STLC V model. The V model, which is include the verification and validations of the structured approach of the software development. The following are the different phases of V model of the STLC. First one requirement analysis, second one system design, and third one architectural design, and fourth one module design, and fifth one coding. In each spaces, in each spaces has a some testing process. We model verification phases. First one, the business requirement analysis. This is the first step of the design designations of the development cycle where product requirement need to be coded from the customer perspective. The phases include proper communication with the customer to understand the requirement. There are very important activities that need to be handled properly as most of the time customers do not know exactly they what they want and they are not sure about it is the time there is use of the acceptance test design. So planning which is done at the time of the business requirement, it will be used an input for acceptance testing. System design. In this phase, the overall structures of the software is planned out. The team developer both high-level design and detailed design. Design of the software system will be start when the overall we clear with the product requirement and the need to design the system completely. This understanding will be the beginning of the complete under the product development process. This will be beneficial for the future executions test cases. Third one is architectural design. In this stage, the architectural specifications are comprehensive and is designed. Usually, several technical approaches are put out and the ultimate choice is made after considering both the technical and financial viability. The system architecture is developed into modules that each handle the distinct function. Another name of this is high-level design. At this point, exchange the data and communications between the internal modules and external systems are well understood and defined. During this phase, integration testers can be created and documented using the information provided. Third one is module design. Fourth one module design. This phase is known as a low-level design. It specifies the comprehensive internal design for the every system modules. Compatibility is between the design and other external systems as well as other modules in the system architecture is crucial. Unit tests are the crucial components of the any development phases since they assist in identifying eradicating the majority of the mistake and flaw at an early stage. Based on the internal modules designs, this unit test may now be created. Coding space. This is where the software is actually built. The developers write a code based on the design created in the previous phase. The coding steps involve writing the code for the system modules they were created during the design phase. The system and architectural requirements are used to determine which programming language is more appropriate. The coding standards and principles are followed when the performing the coding. Before the final and build is checked into the repository, the code undergoes many code is reviews and is optimized for its optimal performance. V model validation spaces. It involves dynamic analysis techniques, functional and non-functional, and testing is done by executing code. Validation is the process of evaluating the software after the completion of the deployment space, development space, to determine whether the software is meet the customer expectations and requirements. First one, unit testing. In unit testing, unit test plans are developed during the module design phase. In this unit testing, plans are executed to eliminate the bug in the code or unit level. Integration testing. After completion of the unit testing, integration testing is performed. In integration testing, the modules are integrated and the system is tested. Integration testing is performed in the architectural design space. The test is to verify the communications of the module among themselves. System testing. System testing is test the complete applications of application with functionality, interdependency, and communication. It tests the functional and non-functional requirement of the developed application. User acceptance testing. User acceptance testing is performed in a user environment that reassembles the production environment. UAT is verify the delivered system it meet the user requirement and the system is ready for use in the real world. Importance of the V model. First one is yearly defect identification. Second one is determining the spaces of development and testing. And third one is prevent the big bang testing. And fourth one is improve the cooperations. And fifth one is improved quality assurance. Advantages of the V model. This is highly disciplined model and spaces are completed once at a time. V model is used for small project where project requirements are clear. It is simple and easy to understand and use. This model focus on verification and validation activities early in the life cycle, thereby enhancing the probability of building an error-free and good quality product. It enables the project management to track the progress accordingly, accurately. The V models provide a clear and structured process of software development, making it easier to understand and follow. The V models place a strong emphasis on testing, which help to ensure the quality reliability of the software. The V model is provide a clear link between the requirement and the final product, so making it is easier to trace and manage the changes of the software. Disadvantages of the V model. The V model is a linear and sequential model, which can make it challenging to adopt a changing requirement or unforeseen events. The V model can be time consuming as it is require a lot of documentation and testing. a high risk and uncertainty. It is not good for a complex and object oriented project. It is not suitable for the project where requirements are not clear and contain high risk challenges. This model does not support integrations of phases. The V model places a strong emphasis on documentations which can lead to an overreliance on documentations at the expense of actual development work.